Okay, so this is a method you guys have asked me, is there a mathematical way that you can actually work out the sequence here? So if I would like to know how many building blocks there would be in picture number 108, is there a mathematical way where I can work out this connection between picture number and the number of blocks? And there actually is. And the way that we do that is we take a term that we call the first differences. We look here at our number of blocks, and we actually take the difference between the answer we got when n was 1 and when n was 2. The difference we get between 3 minus 1 is 2. Then we look at 5 minus 3. That also gives us a difference of 2. And then we look at the next term. 7 minus 5, that also gives us a difference of 2. So we can see that when we take the differences between the number of blocks from consecutive, we get the same number every time. So then we do it again, and we carry on doing it, and we do it over and over again until we get 0. So now we're going to take the difference between 2 and 2. Oh, look, we get 0. 2 minus 2 is 0. The difference between 2 and 2 here is 0. So we go down subtracting until we end up with 0. And the number of lines that we have between where we started and where we get 0, we can see that we had 2 lines here, 2 sets of lines. Here was our first difference, here was our second difference. Telling us that the equation that we're going to get must have the form of a plus b times n. If we'd had 3 lines, we would have got the equation a plus b times n plus c times n squared. If we'd had 4 lines before we got 0, we would have always had the form a plus bn plus cn squared plus dn cubed. And you don't need to worry about why. It's taken mathematicians quite a long time to work with these formulas and come up with them. You just have to know that this is what happens every single time. So if you get two lines of differences before you get 0, you're always going to have a plus bn. And that's easy to remember because you've got 2 terms, 2 lines giving you 2 terms, a plus bn. 3 lines will give you 3 terms, a plus bn plus cn squared. 4 lines will give you 4 terms, a plus bn, and then each time here you can see you've increased the power of n. So 4 terms will give you bn plus cn squared plus dn cubed. So in this particular equation, the only one that we need to worry about is that our formula is going to have the form a plus bn. So let's take away what we don't need. We don't actually need these anymore down here. But we do still need to keep what's happening up here. We know that our equation is going to have the form a plus bn. So now we substitute. What happens when n equals 1 to our equation a plus bn? We look where the answer was. Well, when n equals 1, we get the answer to our equation equaling 1. So when n equals 1, a plus bn must equal 1. But we know that n equals 1, so that must mean that a plus b times 1 equals 1. So a plus b equals 1. Then we substitute instead of n equals 1. What happens then when n equals 2? Well, we have the same equation again. A plus bn equals. And then we look at what answer do we get when n equals 2. The answer to n equals 2 is 3. So the answer to our equation a plus bn equals 3. But we know that n equals 2, so that gives us that a plus b times n, which we know is 2, b times 2 equals 3. So now we have 2 equations and 2 unknowns. We know that a plus 2 lots of b equals 3, but we also know that a plus b equals 1. We can rearrange this equation to get a for it by itself. If we do that, we get that a, so rearrange, we call this equation 1, rearrange equation 1. So we get that A equals 1 minus B. This is very important to be able to do. Now we know that A equals 1 minus B. Whenever we see A in equation 2, instead of writing A, we write 1 minus B, because we know that A equals 1 minus B. So, substitute into equation 2. Equation 2 says A plus 2B equals 3. We know that A is the same as 1 minus B. So we get 1 minus B plus 2B equals 3. 2B minus 1B will give us B. So what we get here is 1 plus B equals 3. 2B minus B is 1B. So now we know that B, we have to take away 1 from both sides of the equation. B equals, take away minus 1 here, and we take away minus 1 there, giving us our new expression. B is going to equal 2. So now we know what the answer for B is. What is A going to be with B is 2? Well, we get that by substituting back into this equation. We now know that B equals 2. So A equals 1 minus B, which is 2, giving us minus 1. So now we know our form of equation. We know that A plus Bn is actually the same as A is minus 1 plus B times n, and B is 2, so it's 2n. So our equation to this is 2n minus 1. We've now worked out the equation mathematically. Let's check that it works. If n is 1, 2 times 1 is 2, minus 1 is 1. 2 times n minus 1, 2 times 2 is 4, 4 minus 1 is 3. 3 times 2 is 6, 6 minus 1 is 5. 4 times 2 is 8, 8 minus 1 is 7. So our final form of equation here is 2n minus 1. And this is a mathematical technique you can do to show, to work out 2n minus 1 if you can't work out that yourself. Okay?